Welcome back. Today is the first day of this week, and this week we're going to try to do one thing, and that's talk about the centers of triangles that are called points of concurrency, and we're going to try to get it all in by Friday and take a little quiz on it, okay, and be done with it, because this stuff can be kind of hard, so we're going to try to just get it done in 1 week so we don't have to worry about it again. Sound good? You grabbed a lot of papers on the way in, so let's take a look at what you should have grabbed. The first thing you wanted to grab was this sheet. Okay, so everyone's looking at this sheet. This is something you can keep, and I'm going to let you use on the quiz on Friday. Okay, now just a reminder, if you got headphones in your ears, your head's down, I want you to be looking up at the front without headphones in your ears, please. Okay, I don't want anything else in front of you, please. I want you to really focus, because this stuff is not the easiest thing in the world, but we're going to make it as easy as we can possibly make it. Okay, so again, and everyone's head up with headphones out of our ears, that'd be great. So on this sheet, it tells you everything you need to know. So I'm already giving you all the notes you need, kind of, okay? So it's got all the terms, median, altitude, mid-segment, angled bisector, perpendicular bisector, and a picture. And what do they mean? Flip it over. This side is what's super important. These top four, as you can see here, these are four different centers of a triangle. Centroid, orthocenter, incenter, circumcenter. Okay, four centers of a triangle. Okay, so usually there's only one center of something, right? But for a triangle, a 2D shape, there are three centers. So today we're going to talk about one of them, the top one, centroid. Okay, now you'll notice the other stuff you grabbed. You got notes. This is what we're going to work on today. And then you got this thing, which is a lot of paper stapled together. Okay. So here's what I'm doing for this week. I'm giving you everything all at once. This may or may not work, because if you lose this with work on it, you've lost your work. You have to do it over again. This week is a week in which you should not lose papers. If you gave me 1 week to not lose anything, it would be this week. So can everybody, okay, understand what I'm saying? Don't lose papers. I give you this to use on Friday. I don't want to have to give you a new one every day. You should keep this all week. I'm giving you an assignment packet. Unless I tell you to tear it off, you're not tearing this off. Okay, keep it all stapled together. Okay, it'll be a lot easier just to be like, there it is. We'll check them, keep them stuck together. Okay, so again, this week is different. You're going to keep things, and you're not going to tear anything off. Okay, the notes will be separate. Those are for you to keep. Okay, so let's talk about centroid. Is everyone with me? Locked in, focused, because this stuff, again, it's not the hardest thing in the world, but it takes a little bit of your focus without headphones in your ears, right? Right. I said it. Here we go. Let's talk about notes, medians, and centroids, okay? So first thing, a median, okay? If you're driving, or if one day you start driving soon, okay, medians are in the middle of a street or a highway, and you don't want to hit them, okay? So it's kind of similar to that, in that it's in the middle. So how do you make a median? So if we read this, it is a segment whose endpoints are a vertex, which is one of those corners, and the midpoint, okay? So how do I make a median? From vertex to midpoint. Does everyone see it over here on this picture? From C to letter D, that's a median, because it goes from a corner to a midpoint. And do you see those tick marks? That lets you know it's for sure a midpoint, because it cuts it equally in half. Okay? So, medians, vertex, midpoint. Now, down here, if you do that 3 times, you see how they're going to cross? That's called a point of concurrency. Okay? Now, I know you know what currency is. Dat bread. Okay? But concurrency is when lines cross concurrently and intersect at one point. Okay, so again, concurrency is where lines cross. And you can see where these 3 lines cross down here at point P. Okay? So we should get a relationship of the segments when we make a centroid of a triangle. Okay? Now, look what I circled right here. What does it say? center of gravity, okay? So I'm going to show you something. All right, so I cut out a triangle earlier. And what I wanted to do was I wanted to make a centroid. And by making a centroid, I want to see, is it a center of gravity? Does it actually balance, okay? I don't know if y'all have ever, do y'all know what a mobile is? Not a mobile phone, not a mobile home, but it's called a mobile or a mobile. I don't know how you say it. But y'all ever seen like a baby in a crib and there's like something hanging on top of it, like a little hanging dangling thing that they look at, goo goo gaga, you know? So back in the day, mobiles were made of triangles. You had triangles that were just balancing there. And the question, it's an outdated thing, but the question is, how do you balance a mobile? Well, you find the centroid. That's how you balance it, okay? So here's the deal. Cut out a sheet of paper, got my triangle here. I want to make 3 medians. So here's how you make a median, okay? You're going to fold corner to corner and then draw a line from that midpoint to that vertex. Same thing over here. Fold these together, draw from this vertex to that midpoint, fold these over here, draw from this midpoint to that vertex. Okay, so I already did it. Here it is. You cannot really see that, which is unfortunate. Yes, you might have to just believe me on this one. There it is. All right. So you see those lines where they cross? That point is supposed to be called a centroid. Okay? So here's the dealio. All right, let's see if I can get this to... Everyone loves this part of it, the demonstration. All right, cool. So, by the way, how about them Cowboys? All right, check it out. So I'm going to take this triangle and this pencil. I'm going to see if it balances this triangle on this pencil tip. Ta-da! Super cool. Super cool. Okay. Anyways, so you see how I did that. I made a centroid. It balances on the tip of a pencil. So bringing it back to the notes, that's why we call it a center of gravity. So does everyone see, hopefully by that demonstration, center of gravity, anytime you see balance, center of gravity, that's what a centroid is, okay? So, moving down here, when you make these 3 medians and you make a centroid, you're going to create some relationships between the segments, okay? So if you look right here on 531 centroid theorem, we already said P is the centroid. So, I want you to look at that right there. Does everyone see in blue I put AP? Right here it says AP is equal to 2/3 of AY. Now, I'm going to be using some terminology to make this hopefully a little bit more simple, okay? Whenever we're looking at these medians, there's a long section, a short section, and then there's the whole thing. Long, short, whole thing. 3 different parts, okay? So, the long section, AP, is 2/3 of the way. The short section, PY, is 1/3 of the way. Okay? So I want you to jot these down for me. Okay? These are 3 little concepts I want you to know. Okay? The long one, the long section, equals 2/3 of the whole. Okay? The short one equals 1/3 of the whole. Now here's something that you got to know also. And it's this one right here. This one some people get stuck on. If you are given the small section, the short section, the long one is twice as big. Okay? So the long one equals 2 times the short one. These are 3 things that we know about those sections. And again, you're going to need to know this for these median centroid problems that will be on your assignment. Okay? We're going to do examples together, but I want to make sure everyone's got this down. All right, let's do some examples of this down here. On number 1, it gives us some information. So first off, it says segment AF equals 9. Now, I like to label AF equals 9 like that, okay? Kind of make a big old bracket. AF, the whole thing, is 9. The whole segment, okay? Everyone's writing this down. Not texting, or looking at our fingers, or looking at other stuff. So again, AF, the whole thing is 9. Now, I'm doing this part in blue. I'm going to skip down to the question, find AG. That's what I'm looking for. Now, think carefully. Is AG the long or the short section? Okay, AG is longer than GF, right? So AG is what I'm calling the long section, the long part, okay? So here's the dealio. What fraction is the long part of the whole? So you look up here to my first statement, long equals 2/3 of whole. So all I got to do is put 2/3 times 9, okay? So the way I would write that, type that in or write that down, AG, that's long section, equals 2/3 times 9. Okay, so off to the left, you can write that down. AG equals 2/3 times 9. Now this might turn into mental math, which in this case is fine. I don't mind. We're not setting up equations, but when we need to set up equations, we do that, right? So 2/3 times 9. If I go to my calculator, I did it earlier. By the way, how do you type in 2/3? You can really just type 2 divided by 3 times 9. Enter. Or if you like to control divide, you can make it into a fraction, 2/3 times 9. Either way, same answer, 6, right? So 2/3 times 9 is 6. So AG equals 6. Was that hard? If you know the whole thing, the long section, just times it by 2/3, right? So let's do the next part. GE equals 2.4. So let's label it. Ooh, sorry. 2.4. Oh, by the way, sorry. Back up real quick. If AG was 6, how do I figure out GF? If I needed to find out GF. So I just want you to remember, the long and the short, the relationship is half of the long one, right? So half of 6 is 3, okay? So now we're moving on to GE equals 2.4. Let's label that in red, GE 2.4, okay? Now this time, I don't have the whole thing, right? So I'm gonna forget about 1/3 and 2/3 for now, okay? Let's just think about what I wrote over here off to the right. The long part equals 2 times the short part. So if the short part is 2.4, how do I figure out the long part, GC? Times 2, right? So GC is going to be 2 times 2.4. So even though I'm looking for CE, this is going to help me get CE. Okay, so GC equals 4.8, right? Small times 2 equals the longer one. So I can label that. I've labeled it them both, 2.4, 4.8. But what are they asking me to find? Is CE the small, long, or whole thing? CE is the whole thing. So how do I figure out CE? If I have my two parts. Part plus part equals whole. Segment addition postulate. Okay, so 2.4 plus 4.8 gives me 7.2. So let me tell you, if you start with one of the parts, you can figure out the other part, and if you need to, add them together. Okay? Yeah? Let's try 2 in a similar way. And triangle JKL, ZW equals 7, LX equals 8.1. So, all right, for WZ, it says it equals 7, so we can label that. And this time we're looking for, we're looking for KW, right? To figure out KW, it would help me to find this long section, right? I know the short section. Let's find the long section. So if this is 7, how do I figure out ZK? Times it by 2. If you have the short segment, times it by 2 to get the long segment. So 7 to get ZK, 2 times 7 is going to be 14, and I can label that on the picture. And then I can answer the question, what is KW? So if I know small part is 7, long part is 14, to find the whole thing, I do 7 plus 14, right? And I get 21. So WK, or KW, is 21. Okay, and then the next thing I'm given is LX. LX is 8.1, so I'm going to label that with a big old bracket. From L to X is 8.1. Now is LX short, long, or whole thing? LX is all the way across. LX is the whole thing. So now I'm going to have to use some fractions to figure out the parts. Okay? So if I want to find LZ, by the way, y'all know who LZ is? Jay-Z's cousin. It was a good joke. Everyone's laughing. There's an uproar of laughter. Okay, so LZ is what fraction? So is LZ the long or short section? LZ is longer than ZX, right? So long is what fraction? 2/3 of the whole, like we wrote up here. So we're just going to take 8.1 times 2/3 to get that longer section. So LZ equals 2/3 times 8.1. And that gives me, in the calculator, I typed in 2/3 times 8.1 up here, and I got 5.4. So that's my LZ. Now I could still figure out XZ, Jay-Z's second step nephew half removed, if I wanted to, by doing 1/3, right? I don't need to, but so let me bring it back for a second. Okay, so was there any questions so far on number 1 and 2? You're basically given something, you figure out the missing stuff based on these relationships, and we wrote in blue what are the 3 different things we could use, okay? So, flip it over. For now, I'm going to skip number 3, okay? And let's go to number 4. Whoops, number 4 down here. Now, the reason why you have a protractor, make sure you flip over here, we're on the back, number 4. The reason why you have a protractor is because you need to make a centroid. You need to make a centroid by graphing, okay? So it doesn't have to be a nice protractor, it just has to have a straight edge. You can pass it back. Okay, so now let's read number 4. What does it say? The diagram shows the plan for a triangular piece of a mobile. Miss Marrero, how do you pronounce that? Mobile? Marrero. Do you say mobile or mobile? Mobile. Okay. So now please remember, mobile. Okay. So a mobile is that hanging thing on top of a baby's crib, right? So just follow along right here. Okay. Let's put that away. So on number 4, where should the sculptor attach the supports if the triangle is what? Key word is always going to be this word balanced. I'm telling you now, okay, on Friday quiz on this stuff, if you're wondering which center is the balancing one, the one that has the center of gravity, it's always this one we learned on Monday, centroid, made by medians. Okay, so notice it didn't say the word centroid, it didn't say the word medians, but you have to know, balancing a mobile is a centroid. Let's do that, okay? Now, here's the dealio. I need to be able to make 3 medians. And what's a median again? Let's go back in time. A median is a segment, and the endpoints are what? Vertex and a midpoint, okay? So here's the deal. I can do that. All I need to do is find 3 midpoints, okay? So I'm going to give you the easy way to find midpoint, okay? You should be able to do it using midpoint formula. You should not ever just guess. So here's an educated way to find the midpoint, okay? Look at point Q and point P. I'm going to think horizontally. How many units are between Q and P horizontally? So you go straight down, you see there's 3 units horizontally between Q and P. What's half of 3? 1.5, okay? So here's the deal. You go over 1.5, go straight up, and put a point right there. So half of the x, and then put a point on the segment. It's going to look like this, okay? By the way, balance, we said, means centroid, which means medians, okay? And there's my blue point that we just talked about. Halfway between 0 and 3 is 1.5. Go straight up, put that point. That's a legit midpoint, okay? Let's do it between P and R. Between P and R, that's how many units? Horizontally? 3. Half of 3 again, 1.5. So go over 1.5, go straight up, put a point there. Should look like this. Okay? Halfway between the x's, go straight up, put the point. Now let's do it for QR. Between Q and R, that's between 0 and 6. What's half of 6? 3. So at 3, go straight up, put a point. So you should be able to find midpoints. Find half of the horizontal change, the change in x, and then find that on the segment, okay? Now, we're going to connect using our protractors from vertex to midpoint. So check this out. From the vertex R to the midpoint across. From the vertex Q towards the midpoint across. Vertex P to the midpoint across. Do you see that they all cross at one point? That's called a point of concurrency, okay? And that's where it's going to balance. I can put my pencil there and balance it. Put a little green dot on it. What's the coordinates of that point? 3, 4. Okay? That's my centroid. Make sure you've written this down. But you didn't. Let's write that down. Okay, so for regular, this class, the assignment, again, this packet, I want everyone looking right here because I don't want y'all messing this up. So again, can I have everyone's head up? Give me a minute, okay? Please. This packet cannot be ripped apart. Keep it all together, okay? You're going to work on it as the week goes on. You're going to have it all in one place. Do not lose this. I can't say it enough. Do not lose this, okay? So, numbers 1 through 4, 5 through 6 are just like the front of the notes. Number 9 is just like the one we just did, okay? So, and I try to make this a little bit easier than the pre-AP classes, okay? So again, one side. That's what we're doing right now. Just like what we just did. Y'all feel like y'all can do it? If you don't, or if you get stuck, of course, Miss Marrero and I will help you out, okay? But all we're working on is this first page of this packet. You're not turning it in today, and you're not tearing it off today. Is that clear? Just work on it, and you can check answers if you need to. Okay, let's get started.